and how they relate to Nazi Germany.
Right.
What was it say?
Turtles.
Literally.
Do you know the Dr. Seuss book?
No.
Turtle the Turtle. Totally modeled after Hitler, and he had a little mustache and everything.
Wow.
He was the king of all that he could see, and he made all the other little turtles stack on top of each other so he could be on top of more things and see more things. And the turtles at the bottom were really kind of getting crushed. And he was defeated because the one at the bottom burped and they all fell in the mud.
So it's like Animal Farm, but with Nazi Germany.
Yeah.
Perfect.
And it's cuter because it's Dr. Seuss. And that's not recorded on
Oh.
how they all good. Okay, so the goal today, I think you guys need to do these problems rather than me do these problems. We should probably walk through this one together because we started it yesterday. But I'd like you guys to do the other ones and we'll go over them. But I'm hoping people to go on the board and like hash things out. The homework tonight is day 41, so it's related rates problems from the textbook. They are tricky. And then Monday we'll go over whatever you guys have questions on from chapter 4. Tuesday and Wednesday's a test.
Good morning, BCC. This is Ms. Rascala in the main office. Please pardon this interruption. All seniors who have registered to take the Avant test today should make their way to the auditorium at this time. Testing will begin promptly at 8 a.m. Again.
Okay. How far did we get in this? Not very. Hot air balloon rising straight up from a level field. What does that mean? Right angle. Tracked by a rangefinder 500 feet from the liftoff point. I don't know what a rangefinder is either. But how do you read that? 500 feet horizontally away from the balloon, like in the air or on the ground? On the ground because it says off from the liftoff point. Does rangefinder sound like it's moving? So rangefinder is static, not moving. At the moment, the rangefinder's elevation is pi over 4, so to me that sounds like it's something that tracks angle. It's looking up.
I think I know what we can do to apply this for me. So this is a problem with the opposite and adjacent. So it's a tan function equation.
Okay.
So pi over 4 would be like the inverse, the negative tangents of
Okay, hold on.
Arctangent.
Eitan, what were you gonna say?
I was just say, since we know it's a pi over 4 right triangle, we know y is 500 too.
Okay, so it said the angle's pi over 4, so the y value is also the same. These guys are isosceles. Brooke, is y static or is the height of the balloon changing? Changing. So there is some dy dt there that is moving. Do I have any other information? Okay. The thing we want to know is dy dt. This is static, and Amir said the thing we should be using is tangent theta. So am I gonna write y over x, or can I say y over 500?
500.
Yeah, y over 500. Why?
You want it to be exact, I think.
Well, it's because I asked earlier, is X changing?
Yeah.
No, it's not changing at all. X is static. That rangefinder is a big old box that sits on the ground. So Nick pointed out we have this d theta dt. So Amir, I would not do tan inverse because one, I don't like doing that derivative. Sasha, what's the derivative of tangent theta with respect to time? Been a while since we've done trig.
Is it like negative or secant squared?
Secant squared theta, and I'm doing the derivative with respect to y or with respect to time.
It's hard.
So I need to add something on here.
So it's d naught, or d theta.
D theta dt. Luke, what's the other side?
D theta dy over 500.
dy dt.
Oh, yeah.
Okay. Easy peasy. I know d theta dt. I'm going to multiply by that 500. Looking at my triangle, do I know secant of theta?
Pi over 4.
Theta is pi over 4. So what's secant of pi over 4?
Root 2.
Root 2.
What?
That's
One
pretty
over
calcium.
500? That, no. What? That's not how, it's not, the derivative of y over 500 is not 1 over 500 dy dt.
It is y over 500. Okay, Amir, what is,
The rules just changed on a whim.
yeah, okay, this, derivative of 2y with respect to t, isn't that,
2 dy dt.
yeah, okay. This is the same as 1 over 500 times y.
Okay.
Did I change the rules on a whim?
No.
Mm-hmm.
Normally you have to do the quotient.
You can do the quotient rule. It's longer and a pain in the butt. Okay, so 140. What are the units? Feet per minute. And those of you who don't, this is 2 times 500, which is 1,000. 1,000 divided by 100 is 10. 10 times 14. So at that instant, the balloon is rising at 140 feet per minute.
Since you know it's like a 45, 45, 90, can you do something with the like Pythagorean theorem to solve for it instead? I know you don't have dCdt, but is that
You need to, the only rate of change they gave you is angle. So you're eventually going to have to do trig in there somewhere.
Yeah.
You could, Amir chose the best trig equation, tangent, because tangent uses a static length. If he chose sine, both things are changing, the height and the hypotenuse, that would suck. So, yeah, you can, and it's not advisable. Okay, you guys set up the equation, work with the person next to you. This is very much like what we did yesterday with the cars.
No, yeah, that's fine. And then right angle intersection. I think it's like this.
since they're going straight east and then towards going to the corner. That's an interesting. Like, if I get to the picture, it's fine.
Sorry, is anyone else missing the sheet from yesterday? Everyone has?
Yeah. Speeding car is going east. Yeah.
Can anyone put the givens up that they got?
Isn't this 20 though?
Brooke, write some givens up there.
And so I was saying that they're both C. Do you care what letters I use? Cruiser and car.
Change, like pick a different letter for, like maybe X and Y because one is moving south.
I'm not sure. Oh, it's Jason, so this isn't.
Well, it's like
Oh,
so,
time.
yeah, so it's like exclusively at a rate. I have it like this.
Oh, no. So we do confirmation.
DY or no, like DY.
Y over time.
Why is it we don't have to?
Negative 36.
Yeah, yeah, because DY is
High
like
five.
car is
1 mile.
Oh yeah, I think it's 1/3 higher.
Oh, yeah.
Like, right. Do we know anything else?
Well, we know that the speed is 60 miles per hour, but we don't know the rate of change.
Yeah, maybe, yeah, we don't know.
Okay.
Okay, and then this one is 0.8.
Okay, what is 0.8? What is 0.6?
Away from the intersection.
What variable? H, C, cop, what is it?
Cop.
So Y.
Y.
0.6 equals Y.
Base.
And what is 0.8?
X.
Yeah.
Okay, good. That was just really stressful. Let's never do that ever again.
You're good.
So do you set up, I'm just express.
Okay, from what they told us in the story, did Brooke get all the information that they directly told us? Yes? Okay. So now what can we pull out because we're smart at math? How do I know what H is? Pythagorean theorem, 0.6 squared plus 0.8 squared, 0.36 plus 0.64. Okay.
It's not actually.
Oh, like the distance.
What else? I need an equation that ties all these variables together. Fiona says find Pythagorean theorem and do the derivative of it. What is the derivative of it?
2x dx dt.
So we're doing the derivative of everything with respect to time. And yes, I can divide everything by 2 just to make the number smaller. And this is why I think these problems are kind of easier because I had to tell you all this stuff. Do I know X?
No, x 0.8.
Do I know dx dt?
Negative 60.
Dx dt, Brooke said that's what we're looking for. So I don't know that. Do I know y?
Yes, 0.6.
dy dt?
Negative 60.
Negative 60. Yeah, why is it negative? Because the y value is getting smaller. So that's a thing to read in the problem. Said the cop car is coming from the north, so it's driving south, going toward the intersection, which means the distance from the intersection is getting smaller. The bad guy car is traveling east. Okay, H was 1, the HDT was 20. Yeah? Anyone finish from here? 70 miles per hour. So this is 36.
Yeah, so here exclusive order.
So I changed the decimals from 0.6 to 6/10 and 0.8 to 8/10 because I can, 60 divided by 10 is 6. Negative 36 add to the other side, 56. Oh, divide by the fractions, multiplied by the reciprocal, stuff comes out 70 miles an hour. Good? So the bad guy car is gonna get away. All right, next challenge. Do you guys even know what to draw? A number of my students are like, what the heck is a conical tank? What do you mean? Is the ice cream cone with the pointy part down? Okay, good. I swear they never had like a sugar cone before or whatever. They had the flat bottom ones. Okay, draw your picture, pull information out.
Yeah, and so we don't know how to figure out the yarn yet.
You have more time drawing. You have actually.
Sorry, not 4/3. I'm refining things.
Oh, okay. That really was like an entire problem. Sorry.
Okay, so 1, be able to draw the picture. It's a cone. The point is pointing down and it has a height of 10 and a base radius of 5. What is DHDT? How fast is the water level rising when the tank has a height of 6 feet deep? And there's my volume of a cone, 1/3 pi r squared h. They will give that to you. And it was on your sheet somewhere. You guys need to remember that the things we did in optimization, there was one that had a cylinder inside a cone and you needed to use the similar triangles and the ratio of things. This tying the radius to height, you needed to see that connection. That if it was absolutely full, the radius to height was 5 to 10, which means if the water's down here and the height of the water is 4, the radius is 2. Like the relationship of radius to height is 1/2. So 2 radius is 1 height. Yes? No? Can I plug in H is 6 and R is 3 right now? No, because as the volume's changing, as we add water, the radius and the height are both changing. So they're both varied. What can we do?
Yeah, one of them by itself.
Okay, I have both of them by themselves, kind of. Like, which thing do you want to get rid of?
I guess get rid of the 2, so R equals 2.
Okay, so volume is 1/3 pi, not R anymore, but what RE is. time you foiled my plan. Please don't do product rule here. Because it's all the same variable, so clean it up. It is pi over 12, where did 12 come from? This 2 is squared, so it's a 4, and it's in the denominator, multiplies to the 3. HQ.
Q.
Jasper, what's the derivative with respect to time? Or the pi. Fiona, do I know all the numbers now? Yes. What is dVdt?
Yes.
9. And I'm gonna multiply by 4, divide by pi, divide by h squared. H squared is 36. So dH dt is 1 over pi. What are the units? Feet per minute. Okay. So Eitan did it the right way that nobody does. Nobody, because you guys are lazy. You're like, you know what? It's easier to, like, I have h equals 2r. So I just want to show you when you paint yourself into a corner, it's okay. So I'm going to do this the non-easy way. So 1/3 pi r squared times height, r squared times what height equals. dV dt equals 2 pi r squared dr dt. Right there is a problem. I don't have the thing I'm looking for in my equation. That's the problem. But it's okay. We're going to just blindly go on through, and we get 9. I'm going to divide by 2 and divide by pi, and r squared is 9. So dr dt is 1 over 2 pi. But I wanted dH dt. All right.
So we have DHT, DRT is equal to DHDT to over 2.
So is there an equation that we use to relate radius to height? Yes. So don't redo the problem now taking out r. Go here, and what's the derivative of that? Exactly what you said. So radius is twice the change in height, so double my dr dt, and I get the dH dt. So don't redo the problem. If you swap out the wrong variable, it's okay.
How is 4.9 over 36 equal to 1?
Oh, it's not 4.9, it's, so dV dt was 9, and then I multiplied by this 4, divided by that pi, like, sorry, the way I see math is not the way I write it well. Okay. Do you guys have any other problems on there? Is this on there?
Yes.
Cool.
Where expand? Yeah, but we don't have that. Yeah. Find the rate. Find the rate at which
Yeah. On part B, what is 25 P? Is that just like, he's not supposed to be there?
Is it just 6?
25 P.
I think that's, yeah, that can't be right. Because isn't this just gonna meet that with this?
So.
Describe this by touching.
Guys, on the sheet,
I
there
just drew it wrong.
seems to be a
But like,
typo.
doesn't see equal X.
There's supposed to be a pile in there on your paper, I think it just says P. Oh. Sorry about that. No, font translation.
Wait 2 seconds. We have circumference. Or for yeah, but each is also equal to 2 times. Can't see, like the,
So, are you on this? Yeah. So, you know, so it's a square, so you know the circumference is just the same as on this side.
oh, we know it should be 6 divided by this. Isn't that like the way to say, wait, I think we do.
No, I
Yeah, I know. But then we don't have a DST.
But if we plug in the diameter of the circle is equal to H divided by
Yeah.
the length of the side.
And it's a square, so it's just all.
The length of the side, yeah.
So 4 S. Where's X? So we don't want to freeze them. So it equals
Triple multiply.
Wait.
We got our like. We have the STT equals something. Square.
So we have.
Oh.
Yes, you remember?
So the way
Cherry pie is delicious. Apple pies are cute. You gotta say like that, so you know it's a cute little extra.
Yeah, 2 pi r times 2 r.
We're the ones that should write on the board.
Just making sure we're doing fine.
Okay.
Yeah.
When r equals p over 8, I'm just gonna.
So basically, the diameter of the circle is the same as the size of the square. So circumference is 10 times. So we find it, and so we want to find how the perimeter can change over 5. So d is pi over 4.
Pi over 4.
Sorry, not, it's pi over 6, but it would still be pi. So pi times six. So 6 over.
Play 6 for this.
6 over.
I know it's deep.
The common standard between the circumference and the perimeter. Since you're trying to find a change of the perimeter on set equation, dp over dt is 4
Oh, is it 4 times? Oh, yeah.
Okay, guys, do we agree? So circle is inscribed in a square. Inscribed means it's inside to the point that it's touching all the edges.
Makes it a little bit.
So circumference equation 2 pi r. Okay, one step at a time, Amir. You haven't looked at it yet. Okay. Well, we're not there yet. So the circumference is increasing at 6 inches per second. That looks like a 5 to me. I'm going to write seconds. So dc dt. As the circle gets bigger, the square maintains its points of tangency. So find the rate that the perimeter of the square is changing. They say the perimeter of the square is 8 radiuses because radius, there's 2 per side, so 8r is perimeter. So they chose to go this way. Circumference isn't 2 pi r anymore, it's 2 pi times perimeter divided by 8. Okay. Which means perimeter or circumference is pi over 4 times perimeter. They're doing the derivative, change in circumference over time, which they have the value, change in perimeter, and so plugging numbers in, 6 equals pi over 4 change in perimeter. Looks right to me. It's all kind of cramped, but do you guys see what they're doing? Did you guys agree with it?
Yeah, we got this.
Okay. And they put the units on it, which are inches per second. Comment on units. M is really popular. Meters per minute, don't write M over M, make something distinguishable. All right, guys.